So this is the third step in the four-step process of reviewing Algebra 1 skills, and it's inequalities. Now, we're going to run into these a little bit, especially when doing systems. So we have to review how to solve those equations and what each symbol means. So the ultimate goal of this video is for you to be able to solve and graph one variable inequalities. One variable meaning just x. So we have to review a little bit of what is an inequality. An inequality is any symbol like this, okay? And you might remember that, all right? Now, oftentimes it's written like x is something 3. Now, remember, okay, the x is not loving something, okay? It is actually less than 3, okay? This means x is greater than 3. This means x is less than or equal to 3. And this means x is greater than or equal to 3. So remember, the alligator eats the bigger number. Okay, always read it from the variable. I can write these the same way. Okay, it's still x is less than 3 because the 3 is the bigger number. Always read it from the variable. So we can reverse these all we want, and they still mean the same thing. Okay, they still read the same way. Now, part of it is you're also going to be graphing these. So you're going to need a number line. Typically, I will provide them for you, but I'm just going to make them up right now. I'm just going to put 3 right in the middle. So the biggest thing is the open versus closed circle. So anytime it's not equal to, so these doesn't have the line underneath, they're open circles. And they point however you read it. So x is less than 3 here. So 2's over here, 4's over here, it's going to point this way. While here, x is greater than 3, and it's going that way. Here and here, they're going to point in the same direction, but the circles are going to be closed. And less than, greater than. So now we can solve some problems. So first thing we're going to do is we got 2x plus 4 is greater than 36. Treat it like an equal sign. Okay, first step, subtract that 4. You have 2x is greater than 32. Divide by 2. X is greater than 16. So now, on a number line, I would locate 16. 15's here, 17's there. Because it's not equal to, it's going to be open. X is greater than 16. It's pointing that way. There's a little trick with problems like this. So the first step, I gotta get rid of the 17. So I'm gonna subtract that. What's left is that negative 3x is greater than or equal to 18. Now I divide by a negative 3. And that's the key. I divided here by a positive 2. I divide here by a negative 3. If I divide by a negative, this inequality flips. Okay? If you divide by a negative, you flip the inequality. So now, I'm at negative 6, negative 7, negative 5. It's going to be a closed circle, and x is less than. It's going that way because I had to flip the inequality. So, whenever you run into a problem that has a negative in front of the variable and you divide by it, you're going to end up flipping the inequality. So these are your practice problems. Please try those. Now, there's also another thing, and they're called compound inequalities. And they're just like solving a regular inequality, only you have to do things twice. So in this one, this is what we call an AND statement. Okay? Because in the end, we're going to find that x is going to be greater than this, but less than this. Okay? Now, treat it just like two equal signs and solve them. So, if I just cover this up, the first thing I would get rid of is this plus 5. So, just do that. Only now, instead of just doing it to the 19, I also do it to the -3. Now, because I'm not dividing, I'm subtracting, I'm not going to change any inequalities. -3 minus 5, -8 is less than or equal to this 2x, which is less than or equal to 14. Now, again, if I cover that up, I'm going to divide by 2 to get this. I got -4. But because I divided by a 2, not a negative, I don't change the inequality. Now I have two things to graph. So on a number line, I would locate. Okay, let's say -4 is there, 7's here. Over the -4 is a closed circle. Over the 7 is a closed circle. And x is greater than -4, but less than 7. They connect, almost like barbells. That's what an AND statement is. Okay? It's the union of the two. It's where those arrows are going to overlap each other. Because if I continue, that x is less than 7, it's going to go all the way over here. X is greater than 4, it's going to go all the way over here. But where they overlap is what we graph. It's called the union, the AND. This is what we call an OR statement. It's what they don't have in common. And they're two different equations. And you're going to see the word OR in there. Okay? So we solve them separately. Plus 2, 3y is greater than or equal to 9. Divide by 3, y is greater than 3. This one I solve. 2y minus 1 is less than or equal to -9. Plus 1. 2y is less than or equal to -8. Divide by 2. Y is less than or equal to -4. You notice that, again, I didn't flip it, even though I have a negative, because I divided by a positive. So I'm left with two inequalities. Y is greater than or equal to 3, or y is less than or equal to -4. So on a number line, I locate. Okay, -4 is over here, 3 is over here, 0 is somewhere over here. Y is greater than or equal to 3, that's a closed circle, going this way. Y is less than or equal to -4, and it's going that way. And I graph them both separately. So that's the difference between an AND or an OR. An AND, I'm looking for what's common amongst the two. Okay, most often it's just the connection between the two. Here I'm talking about what's not common. They point away from each other. So after you've tried these, again, check your answers and then find the learning goal quiz, and you'll move on to linear functions.